Welcome back to the course C# Advanced Language Features. I'm Philip Ekberg, and now it's time to look at a different way of grouping a set of elements. As opposed to using anonymous types, this approach will let you use the definition of the group anywhere in the application. This language feature is known as tuples or tuples. How you pronounce this may vary, but nevertheless, we're talking about the same language feature. The concept of a tuple has been around in .NET for a long time, but in C#7, this became a first-class citizen. The definition of a tuple is that it's a sequence of elements. In C#, this will be a strongly typed sequence of elements. Creating a tuple is easy. You start off with two parentheses. Inside the parentheses, you define the elements that you want to group into this tuple. If you specify that you want to create a tuple that contains the order number and a reference to the line items, you simply add those elements to the tuple. When the compiler sees this, it will generate some code for you. And internally, this will be using something known as a value tuple. The value tuple is a struct, but that doesn't stop it from containing reference types inside the tuple. You can use the var keyword to infer that this is a tuple. And when storing this in a variable, you can of course access the elements within this tuple. As you can see here, just like with the anonymous type, the names for the elements are inferred by the compiler. Remember that the anonymous type had to explicitly define the names when performing a method call. That's not the case with a tuple. If you summarize the price and add the result to the tuple, the compiler will generate a name for you. In this case, since this is the third element, the name for this field will be item 3. This probably isn't the most appropriate name. We could explicitly define the name in the tuple. To do this, you use the same syntax as with named parameters. Specify the name, followed by a colon, and then the value. Now that you've seen how to construct the tuple and give explicit names for the elements in the tuple, converting an anonymous type into a tuple should be rather easy. There are some slight differences that are important to know. The anonymous type is a reference type, and the tuple is a value type. When you create an anonymous type, it will generate a new class that corresponds with the elements used in the type. If you compare that to the tuple, this will generate code that uses the built-in type value tuple. The anonymous type has all its elements stored as properties with names that correspond to either what's been inferred or the explicitly defined names. The tuple, on the other hand, uses fields on the generic value struct. The names inferred by the compiler or explicitly defined will only be tracked by the compiler. When your application is running, you will have no way of finding out what a tuple element was named, at least not without some custom code. Where this can make a huge difference is if you use serialization. Use the built-in support from system.text.json to get a string representation for this instance. You can see the order number, an array of items, and the total price. Sending this text representation to someone else, let's say a web API, that recipient of this text would easily understand what each of the different pieces are. If we do the same with a tuple, the result will be slightly different. As mentioned, the tuples store their values in fields, and by default, JSON serialization only serializes the properties. Therefore, we can immediately see a difference in how you'd serialize this. You'd have to explicitly define that you also want to include the fields when serializing the instance. Looking at the result, it's no longer obvious what each piece in the text represents. Surely, we know that item 1 is the order number, item 2 is the array of items, and item 3 is the total price. Because the compiler translates the code into using the generic value tuple, the names are discarded after compilation. This makes sense when you look at the code that was generated. There is one more important difference between tuples and anonymous types. On anonymous types, the properties are read-only. For tuples, the fields are not. You can change the values after the tuple has been created. So far, a tuple doesn't look very different from the anonymous type and how that is used. We've only scratched the surface. You have now seen how to create a representation of a group of elements. We assigned this group to a local variable, and the compiler automatically inferred some of the names for those fields. When the compiler failed to infer a good name, we could explicitly define that. While we used the var keyword to infer the type, we don't have to. In fact, you can define a tuple signature and the fields instead of using the var keyword. Do this to explicitly define what this group of elements will contain. Next, we are going to explore how this tuple assignment works in different scenarios. And we'll dig into deconstruction of a tuple.